Hi everyone. Today I'm going to be going over my video demonstration for my assignment 1 fall 2025. My name is Uzma and this is my student number. And I'm going to be going over assignment 1, which covers statistical analysis and linear regression and biostat database. These are the technologies we've used. So first and foremost, starting with this assignment, other than stating my name and my student number, which I already stated, we're going to first start off with importing NumPy, Pandas, and Matplot libraries. So just going over what each of these do. So NumPy is basically a package used for scientific computing, and it's used for a lot of arrays and objects to make it more efficient for us to calculate. And then Pandas, on the other hand, is built on top of NumPy and it's used for data manipulation and analysis. And it also introduces data framework and series objects. And last but not least, Matplot is basically used for creating statistical and animated plots and graphs. So it's easy for us to understand what we're looking at. So first question asks us is to import the data. So the data that we're working with is Biostats CSV. CSV stands for comma separated values. So over here, I've imported the Biostats data, and this is the data that we're going to be working with for this assignment. So in order to first do that, we imported the Biostats CSV. We saved it into this variable right here. And now we stored it in that variable, and now we're going to extract the ages that were stated. We're going to extract ages and we're going to save it right here as the variable ages. And then I'm just going to print out the rest of the data so it's visible for me to see. So question 2 basically asks us to do manual statistics without using NumPy. Um, So basically, what are doing here, we're getting the mean ages calculated manually. Then we're doing the standard deviation. We're gonna do the min max manually, and we're also gonna do the median. So all of these processes can obviously be done by NumPy using just a few sentences of code. But right here, we're just gonna do an expanded version of what NumPy does in a faster way. Again, just what I did is I have not used any built-in functions, just loops and basic math. I've also sorted the arrays manually from median calculation. And then the last thing I did was just print out all of the information right here to be seen. As for question 3, it states it's asking us to give the same answer as the question above. The only difference is that we are to also calculate the 30th and the 70th percentile. And the only differences from the second and third question is that we are now allowed to use NumPy. So if we look at the contrast from the question 2 versus question 3, you can really see how condensed question 3 is compared to 2 because of how we are using NumPy. This is a great example and also representation of why NumPy is useful in code. It really condenses all of the confusion that people might have when it comes to calculating stuff. And also comparing my manual calculation with the NumPy calculation, they all seem to be correct. The only difference is that I didn't calculate the 30th and 70th percentile. Question 4 basically asks for a histogram of ages. A histogram is basically a graphical representation of the distribution of numerical data. So the question asks me to create a histogram of age column with the Matplot libraries. It also asked me to draw a vertical line for the mean, median, 30th, and 17th percentile. I've used this function that allows me to draw vertical lines across the axes and also to calculate how many data points fall below the 30th and also the 17th percentile. So over here, I've calculated statistics using NumPy. Then I've drawn the histogram for the title and the axes right here for the X and Y. And then right here with the use of this function right here, it helps me to draw the vertical lines along with a legend right here. And then below, I've also, calculated how many data points it takes to fall below the 30th and 17th percentile. And then later, I have just printed out in words how many data points fall below the 30th and 17th percentile. Question 5 is focused on broadcasting. And broadcasting is an amazing tool that is used for con Yeah, it is broadcasting a powerful tool that's used for allowing different sizes and shapes of arithmetic operations like addition, subtraction, and it's done without creating unnecessary copies of the data. So, what we're broadcasting in this question is converting height, which is originally for inches, into meters, and then weight, which is pounds, into kilograms. So, over here, first I've extracted the columns for the NumPy arrays, and then I have broadcasted inches into meters and pounds into kilograms. And the second question asks us to compute the BMI. And BMI is basically just body mass index. It's just used to calculate a person's body fat. And this is the equation that's used to calculate that. So over here, I've just stated it. And the last question it asks us to create is a z-score. And what that is basically it's basically asking us to show us how many standard deviation each individual age is away from their average age of the group. So it's asking us to do this without using loops. So this is done by vectorized NumPy. So we don't use any loops for this. So over here, I have done the z-scores. And then after, in order to display the data, I thought it'd be best done by a table. And I wasn't sure if I was to do it for all individual entries. So I don't know if it was for the five or just all. So I just did it for all. Over here, this is the data. And then over here is just the styling for the table. Question 6 is basically focusing on Boolean masks and bitwise logic. Bitwise operators are used in Python to perform operations that are directly used as bits, like binary digits. And an example of them are and, or, and not. So using these operators, we are to first create a mask for adults that are under 18. And then also we have to display six different uh operations. And first, what I'm doing is calculating how many adults are over 18 and then storing it into adult mask. Then also with the same operators, I'm going to be asking questions and saving females under 30, asking the questions if the sex is female and the age is under 30, save it into this variable. And also the same thing as overweight with the body mass index, which is under 25. So using this, I have calculated the adults, the females under 30, and the overweight individuals. And I have also calculated counting the average um, and also the median for individuals who are overweight in percentage and also average age right over here. And in order to just display the data, I've just printed everything out and calculated everything out and also showed a summary of the metrics and also the formatting points numbers required for the nearest decimal places. Question 7 is relating to linear regression. So, linear regression is used to analyze to see, in this question, to see how person's age can be used to predict their weight. So in this question, first and foremost, other than importing all of their important libraries, I first did was preparing my data. So first I extracted age column as an input feature, and obviously I used the weight in kilograms. And then I started with my step two right here, which is where I'm going to split the data set. So I'm going to split the data set 80% for training and then 20 for testing. This is going to make it easier for the model to learn from most of the data and then test how well it generates on the unseen samples. Then we're going to focus on fitting the model, and this is going to create a linear regression object that's going to fit the data training. Basically, what we're doing is trying to see if the model finds the best straight line that's going to go between the ages and weight. And then we're going to not finally, but we're going to make predictions and evaluating the performance right over here. See we're gonna see the data set. We're gonna predict into weights and also calculate it into two metrics. R square, which is gonna tell us how well the model fits, and then RMSE is gonna show us the average prediction errors. So a bit about what R square is. The closer R square is to 1, meaning it's a stronger fit, and and lower the RMSE is means it's better accuracy. And then basically what we're doing in step 5 is just literally just plotting the regression. We're just going to be doing the X and Y labels, title, we're doing the grid, and then we're just going to be presenting the data right here. And that basically wraps up all my 7 tasks for my basic statistical regression modeling. And I hope you enjoyed watching. Thank you.